A warm welcome to everyone present here. In today's video lecture series, I am here to present on the topic design thinking based content delivery on slope protection measures. Before going to the topic, let's recall the various topics which we are going to study in Unit 5. So Unit 5 deals with slope stability. In first part, we will be learning about various slope failure mechanisms and various methods of analysis of slopes for stability, and finally we are going to learn about slope protection measures. So as a part of unit 5 in today's video lecture series, I am here to discuss on the topic slope protection measures. So in this video we are going to discuss about the necessity of slope protection, the methods of slope protection, key features, applications and benefits of slope protection. So what slope protection is all about? Slope protection is an engineered technique which is used to increase the shear strength of soil by reducing the driving forces acting on the slope, and also helps to control the surface and subsurface runoff of water by preventing soil erosion. So this is an overall definition of slope protection. So slope protection is used to mitigate the landslides and soil erosion and also surface runoff of water. So why slope protection is necessary? Slope protection is one of a measure to mitigate the catastrophic risk to life and infrastructure due to an outbreak such as landslide. So the slope protection defines various problem, and one of the major problem is to implement measures in order to increase the shear strength of soil or to reduce the driving forces acting on the slope, which ensures the long-term stability. As far as design thinking approach is concerned, we are dividing into 5 stages. One is empathize, next is define, next is ideate, prototype and testing. We are going to adopt this framework in this topic, that is slope protection. Empathize is we have to find out various effects which is causing hazards to the human in terms of loss of life, economic loss, environmental damage, etc. Next thing is we have to define the problem, that is improper stability and decreased strength of the soil and instability of the soil. What are all the steps we are going to adopt in order to improve these conditions? Ideate is the different methodologies adopted in order to provide solution, the best possible solution to the above problem. The suggested methods are geotextiles, gabion walls and soil nailing. Next is development of prototype, that is developing the slope using various software tools and simulation tools such as GeoStudio, Plaxis, etc. And finally testing by construction and implementation of the model. So the various methods are soil nailing, geotextiles and gabion walls. So one of the method is soil nailing. It is a technique where steel reinforcement bars are introduced at an inclined position and shotcrete is inserted inside the holes. That process is called grouting, and the key benefits are It improves tensile resistance of the soil and also improves cohesion and provides flexibility. Next is gabion walls. Gabion walls are cages or cylinder or box-like structures filled with either rocks or concrete, which provide stability, which is made up of mesh baskets filled with stones. It also provides permeability and durability of the structure. Next, final method is geotextiles. Geotextiles are nothing but synthetic polymeric materials which is used as layers which improves the soil properties. The various benefits are it provides separation for different layers of soil, it provides filtration by allowing the water to pass, and also provides as a tensile reinforcement which increases tensile stability of the soil, and also provides drainage for water to flow. So let's summarize the various methods of slope protection. One is geotechnical reinforcement with the help of geotextile. Next is soil nailing by introducing holes provided with grouting in terms of soil reinforcement, and also gabion walls. These are all the three key aspects we have studied in this video, which is the method of slope protection. So let's go for an activity, that is curiosity challenge. So imagine a scenario in which you are a geotechnical engineer hired from a government agency. A crucial section of major highway embankment built on soft clay, silty clay, has signs of instability, that is erosion or landslide, after a season of unusual heavy rain. The sites presents the three conflicting requirements, that is high risk of slope. The slope failure could immediately close the main traffic. An environmental mandate. The agency requires a solution with minimal concrete thus that respects the adjacent wetland ecosystem. Next, the hydrostatic pressure generated due to heavy rainfall. The challenge is to design a comprehensive, integrated, and sustainable slope protection strategy that addresses all three conflicting requirements. So, you are in a position to provide a best possible solution to the above problem. Next, assessment in form of MCQ. First question is, the fundamental objective of all slope protection measure is to increase the ratio of resisting forces to driving forces, known in geotechnical as factor of safety, angle of repose, critical hydraulic gradient, coefficient of cohesion. So what will be the possible answer? So the answer is option A, factor of safety. Next question, what is the single most critical factor that often triggers slope failure? Answer is increased pore water pressure. So among all these factors, pore water pressure plays a major role in slope failure. So the reference links are given below. You can refer these links to get more information on slope protection methods. Thank you everyone for patiently listening to this video. Have a good day.